Okay, I would like to overview the tutorial for module 4. Okay, for question number 1, this is a comprehension question, so you can refer to the notes. I won't explain this one. Question 1. Question 2, briefly explain definition. You can get it from note. Okay, for this one, question number 2, refrigerant. Okay, so let's see. So we have a refrigerant with quality of 100% at 40 degrees Celsius is condensed isobarically to saturated liquid, closed piston cylinder system. Determine the work required. Okay, so it means initially you have 100% quality, 40 degrees Celsius condensed isobarically. Okay, so it means you have T1 equals to, you have T1 and 100% contents, it means everything has changed into vapor. So it means it is saturated vapor. And X equals to 1, right? Okay. And it is condensed isobarically, okay? Isobarically to saturated liquid. So everything has changed into saturated liquid. So what is the requirement of the question? Is to find work. Work equals to PDV. Okay, PDV, which is also equals to V2 minus V1. Okay, V2 minus V1. But if you divide by mass, this one is also divide by mass, you will get small letter, okay, small letter of work, small letter of work, which is equals to P specific volume 2 minus specific volume 1. So how to get specific volume 1 and specific volume 2? So you need to find the from the table. So this is refrigerant. So you need to find table A11. Okay, A11. Find the properties. You will get V1. Okay, find V1. Okay, and for V2, so actually V1 equals to Vg. Yeah, saturated vapor. And actually V2, saturated liquid. Yeah, so actually V2 equals to Vf. So you can find your value and insert, you will get your work. Okay, question number 3. This is spring-loaded. Okay, spring-loaded piston cylinder device. Okay, initially you have P1, you have T1 and volume of V1. Refrigerator is now cool until its temperature. You have T2 and the volume reduced by 80%. Reduced by 80%, it means what's left is only 20%. So V2 is actually equals to 0.2 V1. Right? Okay? By using the information given, determine the amount of work done. Amount of work done, okay. First of all, you need to identify the phase. Okay? Okay. This is refrigerant, so you need to find from, you are given P, right? P1 equals to 500, given is, okay, 560 degrees Celsius. Okay, you can use both, but yeah, it's okay. If you choose A12, okay, from A12, okay, from A12, you can find what is the, from the pressure 500 kilopascal, what is the T set, and you can compare. Okay, so you can compare T, is it bigger or lower than T set. So what is the conclusion? That is the phase. So if you get saturated mixture, it is saturated mixture, so you can find your V1 from your Vf and Vg. Okay, but if it's superheated vapor, you can use table A13. Okay, A13. to get the value of specific volume. Okay, specific volume. Okay, and you might get the mass. You don't have the mass yet. So mass equals to V1 over specific volume 1. V1 is given, specific volume 1, the things that you can get from the value from the table, and you can find the mass. Okay, so when you have the mass, you have the relationship of V2 equals to 0.2 V1. Okay, so it means specific volume 2 is also equals to 0.2 specific volume 1. So if you have mass and you have specific volume 1, so actually you can get V2. When you have V2 and V1, okay, when you have V2 and V1, actually what are you trying to do here is you want to have this. Okay, our boundary P V2 minus V1. Okay, but if you have okay, you have V2 at here. If the pressure is constant, you can use this equation. But if you have P1 and P2 is different, and V2 and V1 is also different, you can't use this equation. You need to use trapezium equation. Okay, so from V2 here, you need to prove whether P1 equals to P2, or P2 equals to P1, or P2 have another value. So from the V2, identify P2. How you can get it? Test using A11. What is the phase? So if it's mixture, P2 is saturated mixture. I said P2 is equal to P sat. If it's superheated vapor, you need to find the pressure in the table A13. Okay. So work of boundary is equals to, if you have two pressure, it means it is area of trapezium P1 plus P2 over 2 specific volume 1 minus specific volume 2. Why is it specific volume 1 minus V2? Because V1 is actually bigger than V2. You're just trying to get the delta V here. So you get the value.